Hello, fellow engineers, and welcome to Polybridge. Wait, sorry, hang on. I'm aping RCE there. Sorry, I should be myself and not try to be real civil engineer. If you're having trust problems, I feel bad for you, son. I got 99 problems, but a bridge ain't one. Hit me! Wait, no. Now that's Jay-Z. This is Polybridge. It's a game where you build bridges and test them and watch them fail spectacularly and hate your life. If you're a big nerd like me, you'll probably like this game quite a lot. I got this game on Steam, specifically a Steam sale for $2.99, and I have had at least $30 or $35 worth of fun out of this game. I have to credit a YouTuber named Real Civil Engineer with introducing me to this game. I've watched him play a lot of Polybridge, so I will leave a link to Real Civil Engineer's Polybridge playlist down in the description of this video. Anyway, I don't want to bore you too much with things like controls or bridge theory. Let's just jump right into one of the first levels, and we'll just get right to actually building some bridges. So we'll just go to the first world. We'll go to the first 10-meter simple bridge. There is a tutorial in this game, by the way, but because I've already done it, it's not going to force me to do the tutorial again, and I will just try and fast forward you through to get to the good parts. First level, just build a 10-meter simple bridge. You can see that the only materials we have available are road and wood, so that's going to cause some design decisions to be made in the way that we build the bridge. These two materials are mostly good in compression, and we'll have to keep that in mind as we actually build the bridge. Now, one thing when you first come into this game, you'll probably get a grid over the screen. The sort of lighter lines are 1/4 of a meter, and the slightly medium lines are a full meter. So if I get a piece of wood, and I start here, and I go to this grid point, you can see it says $180, 1 meter, 0 degrees. So that tells you how much that piece of bridge will cost to build. That tells you how long that particular member...
You said member.
And it tells you, of course, what angle it's at. Now, personally, I kind of find the grid to be limiting once I've gotten good at the game, so you can hit G at any time on the keyboard to just turn it off. And I guess if we just build some pieces of wood in some random order here, I don't think this is going to go very well. So let's just do a simulation by pressing the play button here, and see what happens with this sort of haphazard arrangement of pieces of wood and what kind of bridge that makes. Oh, that's not a bridge at all. That's just some pieces of wood hanging in the air. Okay, let's try this again. This time we'll actually put down some road. I'm going to use right-click and hold to highlight all of this stuff. Right-click, hold, and draw a rectangle. And now that it's all highlighted, I can use this the delete key or D on the keyboard to just nuke it all. Alright, we know we need road for the car to drive on, so let's go down here to our actual road stuff, and I could just hit 1 on the keypad to select the road. Right now you can see the wood is selected, so I'm going to hit 1 on the keypad to select the road. There we go. If I hit 1 again, it'll switch between regular road and reinforced road. I just want regular road right now. Then I'm going to click here on this anchor point. And, I could try my best to keep this level, but it's actually easier to just move the cursor over here to this other anchor point until that little dash circle starts spinning around it. Then I can just keep pressing left click, and the game will just keep building segment, 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 segment until it gets over here. Left click again, left click again, left click again, and the last segment left click. Okay, nice. And then escape to stop building. Alright, let's see if this is a road. I'm just going to hit spacebar to start the simulation. Well, that was a road for about 0.2 of a second. Alright, so clearly that road is very weak in tension, and when its own weight pulls it downward, it's pulling itself apart because it's not strong enough to hold up to the tension of its own weight pulling it downward. So let's just think about our next move here. I guess we really need some kind of reinforcing structure to help this thing hold up under its own weight. And there's a lot of ways that you can do this, but one of my personal favorites, just from pure simplicity's sake, is something called a Warren Truss, which is a wooden structure that goes above the road and uses the compressive strength of wood to hold some of the weight. The sort of signature feature of a Warren Truss is that it's all made of triangles. Let me show you what I mean over on Wikipedia. So here is the truss bridge article on Wikipedia. And specifically, if you go down here, you can see all the different types of trusses used in bridges. Like I said, one of my favorites is the Warren Truss because it's all just made of triangles. So let's go back to our poly bridge and just try and build this triangular truss out of wood and see if we can reinforce this bridge enough that it'll A, hold its own weight, and then hopefully hold the weight of the car too. So, let's see, wood is number 2 on the keypad, so let me just hit 2. There we go, we've got wood. And then I'm just going to start building triangles basically as big and as even, I guess. I guess I'll go with 60-degree triangles. And sure, why not 2.2 meters? I mean, if that's as big as I can make them, then that's as big as I can make them. 63, 65, 60, 60. And you can see, notice this point here sort of lights up and doesn't light up depending on whether I can reach that with my next piece of triangle. So I get this to 60 degrees, and then I want to try and make sure that I see that circle lighting up bright yellow. Good enough. We'll do this. And, you know, I could just keep doing this by hand, but I think it's easier to use my press and hold right click to highlight things. And then I can just copy this with the letter C. So C to copy it, place it down, and then we'll place it down again, and one last time. Okay, that looks pretty good, except these parts up here aren't present. So let's put those in. We'll make sure we're on wood, yep. And then we'll just start clicking in here, and here, and here, and here. And escape to stop. Okay, very nice Warren Truss. The theory here is that if weight pushes down on any of these bottom nodes, it will pull both of these pieces of wood downward with it, and that pulling downward will cause a compressive force to compress actually all of these to some extent. There will be more compressive force where the weight is, but there will also be compressive forces transmitted to the one to the left and to the right, and then eventually those compressive forces will transfer back down to these solid anchor points. So let's run the simulation here. Again, I'm not going to click on the button, I'm just going to hit space, and we'll see. This game has a thing where down here it will actually show you the amount of stress that the maximally stressed part of the bridge is going through. We'll also change the colors of the different pieces to show you how much stress they're in. Things that are red are under super heavy stress, green, not very much stress, yellow kind of in between. So let's simulate this. We'll watch down here for the stress thing, and we'll watch the colors of these different members. Nice. I was looking down here. I don't think that got over 40%. I was wrong. Maximum stress 49.1%. All right. Pretty happy with that. We'll hit this to go to the next level. So in this case, we are going downward, and that means that the parts of the bridge that are down here will get a little bit of the weight from the parts of the bridge that are up here. So we want to make sure that our bridge is pretty strong. We'll try this just with regular road at first, but if we end up having to go to reinforced road, then we end up having to go to reinforced road. Let's see, let me hit 1 to make sure we're on. That's reinforced. Hit 1 again to get regular road. There we go. And then we'll click here to start. And I'm going to go, again, down here to this fixed point and just keep left clicking. And the thing will just start building chunks of road until we get all the way down here. Chunk, 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 chunk. and then one tiny little chunk to finish it off. Alright, fine. An escape to finish. So, in the other one, I knew I could draw triangles at 60 degrees and they'd be perfect equilateral triangles, because in an equilateral triangle, every angle inside the triangle is 60 degrees, but on a slope like this, first of all, let me hit 2 to get wood. You said wood. So... yeah, I don't know. I can't really tell what I'm doing here. So I think it's time to bust out another of Polybridge's tricks, which is the auto-triangulation. If you go up here, you see this auto-triangulate. If I hit R, those dashed lines will turn solid. And then when I go down here, it will actually show me with a dashed line that appears and disappears when I have connections to both of those anchor points. So, sure, why not? That looks fine. Close enough. And then we'll go across here. We'll try and match the slope of this upper line approximately with the slope of these, although I'm not going to be able to get it precise. But what's important here is that I get I see a triangle of dashed lines going all the way down here. Okay. Good. Alright. Almost there. Now this last one's a little weird. You can see that it's a very short section of road down here, so it's not quite going to be like a full equilateral triangle like these. I'll just try and get two things that look like sort of similar size triangles down here. And trust that any compressive forces that come across the top of the bridge will naturally flow downward across this and downward across this. And hopefully, this honestly, because the members are shorter down here, this should be very strong. Yeah, let's just see what happens here. I'm going to hit space to start the simulation, and we can just see if this road down here is strong enough. Keep your eye down here on this little thing that shows the maximum stress. My guess is that the maximum stress on this guy is going to be quite a lot more than it was on the level bridge. Wow. Looks to me like that got up to 73% maximum stress. Yep. So, remember the other one was only 49% maximum stress? This one got up to 73% maximum stress. Alright, cool. Let's move along. So, now that they've given you access to steel, and it's probably... so, down here you see this, steel. In fact, they haven't given you... Have they not given you wood at all? Yeah. No wood possible. They won't even let you build with wood on this. And probably for good reason, because this big yellow truck is pretty heavy. If you hover the mouse over this truck, you can see it says mass 14.0 capital PG. PG is polygrams. That's a special unit of weight that only exists inside this game. The other things we've been dealing with, the car and the van, they were like 5 polygrams, 7 polygrams. So this is like 2 vans worth of weight. It's also kind of slow at 2 meters per second, but whatever. We have a fairly long span here, and we're only allowed to use steel, which is much more expensive on a per meter basis. I'm going to, again, try to do this with just regular road and not reinforced road, and then a steel truss. Steel is interesting because, unlike wood, which is mostly strong in compression and not nearly so strong in tension, steel is about the same strength in tension and in compression. And that'll allow us to do a trick that probably you wanted to do before, and you might have been yelling at the screen, which is put the supporting structure underneath the bridge. Here's the problem. When you put the supporting structure underneath the bridge, the bottommost members are in tension rather than in compression. So if you build an underneath reinforcing structure out of wood, you're not using wood's heavy compressive strength. You're trying to use its much weaker tensile strength, and your bridges will tend to break. Anyway, let's get some road out here. You know, no, I'm not going to show you the path tracer tool quite yet. We'll save that for a little bit later. Right now, we can still get away with straight lines. We won't have to do arcs, and so let's just do straight lines when we can do straight lines. So I'm on road. We'll start here until the road comes all the way across. Oh, look at that. It's going to be a sort of integer number of these road sections. 1, 2, 3, 4, 5, 6. Nice, nice. And then, because steel is sort of equally strong in both tension and compression, we'll try and build what's called a bowstring truss. This is a Warren truss. Well, it can be a Warren truss. Bowstring truss can be a lot of different things. Let's pop over to Wikipedia and we'll take a look at it. Bowstring truss looks like this. And you can build it either above or below. But you can see that over here near the edges, the triangles get smaller and the top arc, or the top members of the bridge, come down to the same point that the bottom of the bridge, or the roadway, is touching. That's particularly good in tension, so it's also usually uses less material than something like a Howe truss. So let's go ahead and do one of these underneath with steel. And I'm going to go ahead and leave auto triangulate on. And we'll just kind of go vaguely in an arc. This is the very middle of the bridge. So I'm going to go straight down from the very middle of the bridge here. And now I want to show you a trick that's really useful. I'm going to delete this. Now, if you've built half of a bridge and you want the other half to be exactly the same, you can do a trick where you copy something. You hit C to copy it. Now we have this half of the bridge. I would kind of like to put that over here, but I need to mirror it across a vertical axis. And it turns out you can do that by flipping it. See, it says horizontal flip F here. F. Boom. Now we have a perfect mirror image. And we can just do... Actually, you know what? I want to delete this just in case. I think it will automatically delete duplicate structural members of the bridge, but just in case, we'll delete that. And now we will copy it, put it down here. You can see when you've got it right on, it'll stop, the red crosses will go away, and it will turn to green bow ties. All right. Let's delete this with our sort of hold right-click and select. And then D to delete it. Looks pretty strong. But I'm still a little bit worried that when weight comes down on these road sections, the steel may flex some as the load goes on it. And that could allow a tension load to pull apart one of these bridge sections under the heavy weight of this truck. So let's see what happens here. I'm going to press space to start the simulation. Oh yeah, no problem. What was that, 60-something% maximum stress? 61%, just under 61% maximum stress. And that's the power of steel, my friends. It's very, very strong, and the other thing you notice is that I'm allowed to make steel members that are up to 7 meters long. Or sorry, up to 4 meters long. Whereas with wood can only go about 2. Steel allows a lot of really great stuff, but it's much more expensive than wood. You can see that there's a budget up here. You don't have to come in under budget, you can build bridges that are over budget. But it is a nice secondary goal. After you get a working bridge, then you can make it cheaper by sometimes replacing things that are steel with wood or other tricks. I didn't want to tell you about that quite yet, but I guess it's time. All right, run the simulation again with the spacebar. Just looking at the little down here. They're turning orange, but not really red, so they're not under heavy stress or anything. It's all good. All right, cool. Let's go to the next one.